Good morning, everyone. Today I want to talk about your new assignment. Assignment 4, the idea is to open the assignment today and it will be due by Friday. So Friday, all day, you have the full week to work and contact us if you have any question. The assignment, the idea is to put together architectural patterns with design patterns and programming. You are going to submit Java files. You are going to program something. I am going to explain what. That's it. Java programs. The assignment, let's see. I am going to explain the requirements in the video so you can go back and review this as many times as you need. So we're going to start with a model view controller. Your assignment is going to have a graphical user interface and it's going to have interaction with the user, controller, listeners. You can be thinking about JFrame for sure. You're going to need that. You already have examples with that. Controllers, listeners. In particular, something that I am going to do this time is let's stop the action listeners. You already know how to use them. Let's play also with the mouse listener. It's a listener, should work in the same way. The only difference should be now we are using the mouse instead of a particular control on the screen, but the mechanic should be the same. Anyway, and a functionality, the model. For the functionality, let's use here something that allows us to have not only this model view controller, but also a Blackboard pattern. Let's put the Blackboard pattern and use for your reference the repository of the information, working with a knowledge source, student that we named, and the control, the professor. Let's do something in which we need a repository of information and at least 2 elements working. Usually for the Blackboard pattern, you have several of these. That was the rule, several knowledge sources, 1 control. Here, for the example, I am going to use 1 and 1. 1 control, 1 knowledge source, and the common repository. This one, as we reviewed before, is all about some kind of actions happening with data. This one is a good pattern to use together with the model view controller. So I am going to ask you to do something like this. A model view controller for the global application and for the model, for the functionality. Our functionality is going to be something related with handling information. Moreover, handling information in 2 processes, working at the same time, quotation marks, with whatever is the data here. Somehow, your view is going to be working with controllers, listeners. Those listeners are going to request actions from the model. The actions are going to involve control, knowledge source, and Blackboard. And in some point, we're going to have results. And those results should be communicated back to the view so the user is able to notice that something happened. This is the big picture. This is the architectural part. And again, the arrows are not the UML arrows. The arrows for the architecture really represent communication in one way or in the other. The arrows here are not association, composition, aggregation. It's just boxes with arrows that help us to understand what is happening. And most of the time, the flow of the information. A simple picture. Now, with this architecture in mind, next step, what is going to be the program? And therefore the classes, and therefore the source code. Let's see. First, for the view and the controller, these 2. I am thinking about the following. I really want to have the controller, the listener, in a different class than the view, in a different class that the classes that are showing everything on the screen. The beginning of your application doesn't matter what is going to do the application yet. But if we're talking about a view and we're talking about the listener for the mouse, this is the beginning of my class diagram. I am asking you to have one class for the main method. That is usual. You need a class for the main method. Now, you know what? You can use that same class and inherit from JFrame. Oh, that one, the main, is going to be your frame. And what can you do inside of a frame? You can add elements. Elements. In particular, I am going to ask you to add a canvas. A canvas, that is going to be the name of the class, but that one is use a panel. You're going to have this, a frame with a big canvas using the full screen. Very similar to what you have with the Pac-Man. Use one frame with a full canvas using all the screen, all the frame. This one, this result is these two classes, the main for the frame and the canvas inheriting from panel. My class diagram, two inheritance, two classes, main and canvas. Now, moving forward, another thing that I need is a listener. In particular, I need a mouse listener. Listeners are part of the controller in the architecture. So I am going to use the mouse listener. Now, in order to create a listener, is an interface, I need to do inheritance, realization. I am going to have another class, reporter in this case, and that one is going to be a child of mouse listener. So I have a child of a JFrame, I have a child of a JPanel, and I have this child of mouse listener. Finally, I need to connect my application with the listener, my view with my controller. That connection is going to be here. It's going to be there. Hopefully at this point, you are imagining the source code for these classes. You are imagining thinking about what is going to be the source code for the main, for the canvas, for this reporter. Important things for them. We need a constructor here. We need the main. The reporter, all the methods from the interface should be implemented. For the canvas, the important thing, the important one, this paint component. And I am going to talk about the update later. But the important thing in the canvas, the paint component, the one that we used to do the game, remember? So, okay, I have my graphical user interface and I have a controller, a listener. This is going to happen when I run the program. And source code. Just trying to help you a little bit in the view. In this program, in this class that is your main, you have a constructor. And that one, I am asking you to have a canvas. Hopefully we agree that if you have this class main, and I am asking you to have a canvas, and the canvas is going to use the full screen to create this, the source code that you need to create that part of the application, and you have used this before, is something as simple as creating an object, canvas. I am asking you also to connect with the controller, that is a class reporter. Therefore, if you are going to use this, and if you are going to use this, in order to use them, you need to create the objects. Create the objects. I am not using the ammons for the relationships. Therefore, those objects are local variables in some method, probably the constructor, but there is no diamonds in the class diagram. There should not be global variables in the class main. Anyway, two objects from the two classes that I want to connect. Then, well, you need to establish somehow a layout for the application. You have two options, border layout and add the panel at the center, or grid layout, a grid one by one column, one row, add the panel there. Any option can work for you. I follow the border layout. You need one of these lines. Then add the element. Then add the listener. That's it. Add the element, it's going to be visualized. Add the listener, any information about the mouse is going to be sent to this class. I think those are the most important lines that you need in the main class, in particular in the constructor. Those are the lines that connect what I am showing you in the class diagram. Those are the lines that connect this and this. The inheritance, I am sure that you know what to do for this one and for this one and for this one. So the lines that I show you hopefully help you to start with your application. Moreover, in the reporter, it's going to be mandatory for you to implement all the methods that the interface is asking you to implement, and the names are in the class diagram. However, the only one that you will need for what I am going to explain now is one of those methods. One of those methods could be this one. Every time that you click on the screen, this method is going to be called. Remember, it's a listener. It's like an observer. It's observing that every single time that you click over the panel, the method is called. The method is called and receive information about the event, receive information about what the method observed. And in this case, these two instructions are going to be important for you. You can get the exact coordinates, X and Y, in which the user makes the click with those instructions. Get X, get Y, and use the parameter. That's it. Step number one, my recommendation, you can create your view and your controller. And with this source code, or more or less with these ideas, a first review that you can do is print something on the screen. Print what? Those numbers, X and Y, just to be sure that your view and your controller are working, that your view and your listener are correct. Remember, do not create software programming everything in one step and try to review at the end if that thing is working. Step by step, incremental. Now, what you should have at this point, following the class diagram and maybe using these hints, should be an application in which I have this window, and every single time that I move the mouse and I make a click, for instance, click here, immediately on the console, I am going to read this line. You make a click, the coordinates 1452, more or less there. If I make a click maybe around here, it's going to be something like that. I am doing my screen 500 by 500. Is something that you specify in the main, if you remember the games. Another click maybe here and here and here. And I am basically testing that my mouse listener is working and my panel is working. I make the clicks. Nothing happened on the screen yet. Nothing. And The only thing that I can check in order to be sure that it's working is my console. These messages should appear in the console. That's it. Step number one, a panel, the mouse, and I know the position of the clicks of my mouse. Good. This is only my view and my controller, nothing else. Moving forward, if I have this view and this controller working, something like the class diagram above, frame, panel, main, canvas, MouseListener, the reporter, that part is working. Now, let's work with the second part, the model. Now, the model is this Blackboard pattern, something we can do there. Step number one, what can we do? Well, what about as a step number one, using the Blackboard, the common repository for the information? What can we do with the Blackboard? What can we do with the common repository for the information? Put information. Put information means that this connection here, the connection between the controller and the model, well, step number one, that connection is going to become the reporter accessing the Blackboard. If you want to think about the controller being another knowledge source, that is correct. In this case, I am only using the controller to initialize, to insert data to the Blackboard, to the repository. I am giving the controller a position as these guys, another user of the repository. The repository, before telling you what is going to be inserting there, the repository, things that we can do with the repository. Number one, we're going to have only one repository. Having only one repository is asking me to maybe implement the singleton pattern. Singleton pattern. The main reason because I will recommend you, and I am asking you to implement the singleton pattern, is because it's going to make easy to access the repository. Remember this singleton dot get instance in any place, and you have access to that class. You have access to whatever is inside. It's easy to access. So that is a good approach for this Blackboard. Blackboard in the architecture is this block, but inside we can have as many classes as we need, use like with the others. So in this particular case, it's like, let's create a class. One class, repository. That class repository is going to be a singleton, so it's going to be easy to access. It's going to be a singleton, therefore that class has one variable, and that variable is static and is from the same class. If you do the diagram, you have either the variable here or this loop here that is the indication that is a singleton. It's using a variable and the type is the same class. Moreover, you can remember the private constructor and the static get instance method. Good. Now, what I am going to have inside of that repository? Well, you know what? Two things. This repository is going to have a lot, asterisk, points. Points. What is going to be point? Point is going to be a class and only have two variables, X and Y. I am going to store in the repository. You can think about a database, and I am going to put inside points, objects with an X and a Y coordinate, objects with an X and a Y coordinate, object with an X and a Y coordinate. Where are going those objects come from? Here. Let's see. Every single time that the user make a click on the screen, I have the data from the X and Y coordinate of that click. What I am going to do with those data, I am going to create an object with the X and Y values inside. And that object, I am going to put that object inside of the repository. Anytime that I make a click, I insert a new object. So at this point, you can be thinking like, well, this asterisk here, as we talked before, is going to be a data structure. Moreover, it's going to be a data structure that is going to be dynamic because the repository is going to have 0, 1, 2, 3, n number of points. What I am going to do, well, is a singleton. Therefore, this class should be able to access the singleton, as you know, get instance. And then having the instance, I am imagining that it should be some kind of method here for adding points, for inserting data, right? So step number 1, controller, insert the data into the Blackboard, in particular in the class repository that is connected with a collection of objects, points. So far, hopefully good. Now, no diamonds yet. Answering the question, so far, I do not have diamonds here. Options for diamonds and something that I want to talk about that in the next slides, but hopefully you agree with me that if we start thinking about diamonds, the good place for diamonds is going to be this connection and this connection. And I am adding there question marks for, is going to be a diamond black or is going to be a diamond white? What is the relationship between the repository and points? The only thing that I mentioned to you, and I want to insist, is an asterisk there. There is 0 or more points. Later, I am going to mention another class, lines. And as you can imagine, it's also going to be lines, 0 or more. I am going to talk about lines in the next slides. But repository is this Blackboard, and you can put there points, X and Y coordinates, and later lines. Lines are 2 points, right? The beginning and the end. Well, points first. If we have the repository, if we insert points, and that is done, the next step is, well, when I click on the screen, nothing happened, even though I have the information. If you want the user to notice that we catch the click and you want something to happen in the position in which the user made the click, you need to update the view. For instance, here, in order to update the view, a good idea could be that the view is observing what is happening in the repository. So this is kind of the connection between my model and my view. What can be observing? Well, what about observing every single time that you put a new point on the repository or a new line? Let's start with the points. If I notice that a new point was added in the repository, a new set of coordinates, X and Y, then I would like to be notified. In particular, the canvas is the one that want to be notified. Yeah, that is true. This X here and this X here come from Asta. I am using Asta to do this, and well, the X's, the points in which I can move the line. So don't worry for the X. Observer and observable. What I want to achieve is something like this. In my previous version, I make the clicks Nothing happened in the view, but I have the information. If I close the loop and I use the information to create objects, put the objects in the repository, I make the repository observable, and I make the view observing the repository, closing this loop of connections, what I am going to get is every single time that the view observes a new value in the repository, I can paint something using the paint component method. For instance, if I make a click here, now I have the coordinates. The coordinates go to the repository, and then the view is able to paint a circle in a blue color in the same coordinates. So that is going to give the user the idea that every time that I click in some space, a circle appears in that position. I want to make this clear. You should program this. You make the click, the notification go. The data should go to the repository or to some place, and the view need to be reading that data. And with that data, doing something like drawing. You already know how to draw things. You already know about the paint method. You already know about the observer, the update method. The only thing that we need to do is to put things together. Hints, things that you're going to need, I think. You need to add an observer. You need to add Canvas as an observer. Canvas as an observer of your repository. Your repository is a singleton, so you can access that with this repository.get instance, right? Obviously, this object Canvas that I showed you before, that one should be observer. That one should implement observer. On the other side, the repository, that one should be observable. You already know how to connect that, right? Finally, in the controller, in that MouseListener situation, when you receive a new coordinate, you need to send the information to the repository. Sending the information to the repository, well, with this, you get access to the repository. What do you do here? Maybe call a method add point. And remember, you already have the variables X and Y. I showed you the data. Something is going to happen here. You're going to connect with this line. This line is this call, and you're going to use the parameters that you already have. This connection that you're going to do with the view is the connection between these two classes that you do not need to show in the class diagram because it's a connection with the API. But you know that an observer and observable are connected when you call this. You have examples with this before. At this point, what you have, or what you should have in this second iteration of the project is, well, now this should be working. I run my program, I make a click in some space, and the data is in the repository, and a blue circle, or you can use whatever color you want, is going to appear on the screen. You define the color, you define the size of the circle. These are size 10 pixels, but you can make it bigger or smaller, more like a dot or bigger circles. I have this on the screen. Very trivial, very simple application. But what I have in my source code is all these classes working, a singleton, an observer, listener with the mouse, a graphical user interface. Good. Now, more hints. This. What do you need to do in order to print the circles? As you remember, the important method is paint component. And as you remember, paint component is the one that paints the screen. It is the only place in which you can paint something. And the only way to call that method is automatically when the frame appears for the first time, or if you minimize, maximize, or if something covers the paint, that is going to be called automatically. But the second way to call it is with this method, repaint. If you go and review your Pac-Man games and things like that, you already use paint component, you already use repaint. What I am thinking that you can do is, well, the panel is going to be observing the repository. Every single time that the repository has something new, it's going to call this method update. This method update in the panel. You know what? This method update, what the method can do is call repaint. If you think about the full idea, every time that something happening to the repository, the screen is going to be repainted. Repainted with what? Well, I would recommend you something like this. Repaint. Repaint what? Well, you know what? Use the repository and get from the repository, for instance, all the dots, all the points. What data structure are you going to use? Up to you. I just make this example using a stack. So basically in the paint component, I connect with the repository and I ask repository, send me all the dots that you have, send me them in a stack. It can be a list, a tree, whatever, a data structure with all the elements. And the only thing that I do is an iteration. You can use something more fancy. I am just trying to facilitate the reading here. You do a loop, 0 to the number of elements in the repository, the number of dots. And for each of the dots, they are objects. Get X, get Y. They are objects with those two values. Get the values. And with those values, draw an oval. Remember, the draw oval is going to draw a circle. The X and Y is the upper left corner of the circle. So if I really want to draw a circle that is in the middle of the click, you can do some tricks like minus something, plus something. So the circle is going to be more or less in the position of the cursor when the user makes the click. For the Y in particular, remember, you have this window, but the window have this bar. So you need to consider the size of this, depending on your program, around 20 pixels. So that is my tool there. One approach, there are others. This is a loop in the paint component that is painting all the dots every time. You can figure out something similar with lines. I am going to talk more about lines, but if I have another repository and that other repository have lines, well, the idea could be very similar, but I have another method, and that method needs 4 numbers, XY for the first dot, XY for the second dot. I can put that in a loop, and I can be drawing lines, not only the dots. One loop, a second loop. Here is going to be for you. The listener with the update, the repaint, call the paint component, paint the dots. This should be working. So far, hopefully at this point, you have a second version, a second beta version of your program. It's running, it's a graphical user interface, you may click, you can continue checking the console for the coordinates, the thing that is going to go to the repository, but also now you can saw blue dots on the screen in the same place that you make the click. And this is going to be almost real time. You make the click, you saw the circle immediately. But what is happening inside is all these classes working. These calls and, well, the connection between this observer and observable. Not yet. I am going to talk about the lines. Give me a minute. Right now, the only thing that you have is this class is working with only points, a repository of points, and the functionality is this functionality, no lines yet. Good. That could be version 2. It's like if you want to put milestones for yourself, is milestone number 1 without the dots, only the graphical user interface, the mouse listener working. Milestone number 2, now I want to show the circles in blue in every place that I click. And what I should have working is these classes. This is more or less your class diagram. And those red things additionally. So far, it's like, okay, I have a view, I have a controller, my model is only the repository, I am inserting into the repository is observable, and the view is being updated according with whatever happened in the repository. Final step to complete this. I need to do something with these two guys. For those two guys, easy. And here I am moving to functional requirements. I try to give you what you need for the first step, less information for the second step, and for the final, I am going to give you kind of a more open description. Open description, you have this working. You have a Blackboard. You can access the Blackboard in any class. I need a class at least here for the knowledge source, maybe a student, if you want to follow with the names that you used before. I need a controller, a class here at least. If you want to use professor or leader or whatever name we used before, it's fine. They are going to be using the repository because the repository is a singleton. The connection between them and the classes that we already have is going to be used aligned. They are going to be calling methods in that repository. Use the same that happened with the controller, with the mouse. It's just aligned. There is no diamond involved because it's a singleton, therefore unique, therefore everyone have access, just calling class and the static method get instance. There is going to be a connection like that. This one, the student, I want that one to be a process. I want that one to be one part of the program that is always running, doing something. The same for professor, which basically means that in a class diagram, these guys are going to be implementing Runable. Something like that. Good. Runable, and therefore they are going to have a method run, and that method run is like the main for those processes, right? They are going to be doing something. Doing what? Well, easy. The student. Every single time I add a new point, I would like to connect that new point using a line with the point that is closest to that one. So are you telling me that you are going to make a click here? That one is the first point, nothing happened. Then I am going to make a click here. That is the second point connected to the closest one. I want a line connecting those two. Okay, but then you are going to make click again in another part. Let's think about here. I want a line connecting this one with that one. Okay, and then you are going to make click in another place here, another place here. The dot is the position in which you make the click. The line between the new dot and the dot that is closest to the new one. What can I do to get dot that is closest to the new one. Calculate the distance between the dots. Yes, you need to calculate the distance between the new dot and all the others and check which is the distance that is smaller. And that one is the dot that you want to connect with the new one. Needed neighbor. There are several different algorithms that you can use. I am not asking for any particular one, but usually even the most naive algorithm is going to be order 2 or something like that. I am fine with that. Don't worry. So the line, you need to calculate a new line for the new dot connected with the one that is closest. Now, what happened? You calculate one line for the new dot, but every single time in the screen, you should have all the lines. And what you need to do is the same thing that we need for the dots. Every time that a new dot is created, we insert that dot in the repository. And everything that we repaint the screen, we paint not only the new one, but all of them. Remember the 4 that I showed you? For the lines, the same approach. Every time that you connect a dot with another, what I am asking you to do, this guy, to be clear, is not going to draw anything on the screen. This guy is the model. The model is not going to be painting anything on the screen. The only thing that this guy is going to do is to calculate which is the dot that I need to connect with. And then he's going to create an object line. That object line have the information of the coordinates for the 2 dots, and he's going to insert that line into the blackboard. So the blackboard have this collection of dots, and also now the blackboard is going to have this collection of lines, well, objects with the data for the lines. Every single time that you add something new to the blackboard is being observed by the view, the panel. The panel is the one that is going to take all the dots and draw the circles in blue. The panel is the one that is going to take all the lines and draw the lines on the screen. For the user, it's like, well, this is happening. I am making a click, a circle in blue appears with my click, and in some period of time, seconds, depending on your computer, depending on how fast you calculate the line, in some point, a line is going to appear, and the dot that I put is suddenly connected with another one, the closest one. Makes sense? So everything is about the repository have the information for the dots, the repository have the information for the lines, the view, the only thing that the view do is checking the repository, draw whatever is there. These actors that I have here, they are working with the repository, not with the screen. They never communicate with the screen. The only communication with the screen is this observer pattern between the repository and the panel. These guys, even the controller, they are inserting data to the repository, inserting dots. This guy, the new one, inserting lines. And one last thing. We have this control. Control, as I mentioned before, is another class. That another class is also a runnable. Is running probably at the same time that this one. This one is inserting lines, is calculating the connection of the new dot with something that already exists. This one, what I want to do is to delete both lines and dots. Which is going to be the criteria? Well, randomly. If I have a dot and for whatever reason, this dot is connected this one with 5 more, delete the dot. But if you delete the dot, also we are going to delete the lines. Well, to make things easy, delete the dot, delete all the lines, and recalculate lines. If a dot have more than 5 connections, no, if a dot reach 5 connections, when the dot reach 5 connections, that means there are 5 lines using that dot. In that point, I delete all the lines, empty the repository of lines, and delete the dot. Somehow recalculate all the lines. Somehow, with the dots that are still in the repository, recalculate how to connect them. I am thinking in a method, needed neighbor, and that method is the one that is going to calculate these connections. And that method can be called by these two guys, used to avoid repeating code, right? They are going to do the same. Every single time that a new dot is added, when one is connected with 5, delete, restart the lines. Important thing, the big problem that you're going to have, a problem that in particular I want you to put attention. When this guy is working, the controller, I am asking you to delete something. Delete. It could be a good idea that this guy, the guy that is adding dots and also adding lines, kind of stop, because there is going to be some kind of competence here. But those two guys cannot connect directly. According with the pattern, the only way to connect them is using the blackboard. One idea for you, what if the first thing that the professor do is to put a stop in the whiteboard? You can think about a flag, a variable, another that is not only the repositories. When that variable have this stop symbol, when that variable is true or false, this guy do not do anything. This guy stop. So that give opportunity for the professor, the controller, the leader to delete things and recalculate things, and then this guy later can continue. Because again, the professor is going to work only in very particular situations. And that's it. Data structures, whatever you want, the number for the connections, 5, exactly 5. So is if you have 5 connections or more, if that is the case, yeah, delete. I didn't mention the semaphore, but yes, I mean, what I am asking here, if this were a distributed system course, could be the implementation of a semaphore in using the repository as a data structure. I do not know how familiar you are with some topics. So really what I am doing is trying to keep things open. Needed neighbor is a naive algorithm. If you are more familiar with better algorithms for connecting dots that are close, go ahead. If you know about semaphores or synchronization things, you can go ahead. I mean, I am pretty open with the details of the implementation. My goal is, I am giving you these 2 architectural patterns. I start doing the design for the view, for the controller, for the repository. And I have these 3 big question marks for you. How to implement the leader, the control, the professor, how to implement the student. The only thing that I am asking is these both are threads, therefore runnable, both as we described before. And obviously, well, there are going to be some connections missing here that you are free to add. Good. Any question regarding the requirements? You can work alone or you can work in a team of 3. So up to you. In the previous assignment, some of you expressed that you want to work alone is better. Some of you talk about teams. So I am open. You can decide teams, 3, 2, or you can be alone. I am fine with those options. Submission, only 1 person submit. And please, if you're working in a team, be sure to add the names of your team members. More assignments. Remember, assignments are 25%. Quizzes are 25%. My goal is that we do at least 5 quizzes, 5 assignments, So each of them could be 5%. If we can do more, the better, because then the value of each of them is lower than 5%, which could be good for some of you. But well, at least 5. So this is the number 4. You can expect at least another one. No, I do not drop anything. You can have additional data structure in the repository. Yes, of course. At least you need a data structure for the dots, a data structure for the lines, or maybe you can have only one for lines and dots, up to you. But if you need more, like a variable for the semaphore, go ahead, or you need to count which point you have used and which not. You can add more variables, more data structures. Again, the repositories use this class that have all the data that you need. Good? Okay, guys, I will stop here. Thank you.